just like any algebraic equation. So you guys are working on this in the back of your homework spiral. Section 3.1, challenge problem, sure. Opener, sure. But my advice was to divide by 2, but in dividing by 2, this one could be. So what was the second thing I said? Yeah, I thought that would be smart. Just as far as being easier on your brain, does that also reduce the 2 away? Yeah. But why is it nicer over here? Yeah, it's a lot easier to visualize, right? So you ended up with 3 to the 1 minus x equals 1/9. Do you guys remember what my third clue was? Use powers to rewrite denominators. So I can think of 1/9 as 9 to the negative 1. Now, I don't want 9. I want a 3. So I can make that 3 to the negative 2 because a negative puts that base in the denominator and the 2 squares it. So I would have 1/9 with 3 to the negative 2. 1 over 3 squared, 1 over 9. And then why is that so amazing? As soon as I can make the bases match, what do I get to do? Solve for x, because I get to just look at the powers. Does anybody remember from last night what the snazzy name is of that property that lets us just look at the powers? 1-to-1 property, good. So x should equal a positive 3. Subtracting the 1, negative 2 minus 1, negative 2 plus a negative 1 is negative 3. Dividing both sides or multiplying both sides by a negative would get rid of it. So x has to equal a positive 3. If you guys weren't totally solid and sure about whatever answer you kind of thought of, you could have gone back to the beginning and said 2 times 3 to the 1 minus negative 3 equals 2 over 9. Not negative 3. I plugged in the wrong number. It's a positive 3, right? And 1 minus 3 would be 2 times 3 to the negative 2. And that'd be 2 times 1 over 3 squared, which does end up equaling 2 over 9. Dun, 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 dun. Who beat me to 3? 3 was what you thought? Jason was like, I have an answer, but I don't know why. Only like 3 of you. Give me a thumbs up, though, if you're like, I think I followed the steps. I think I know what went on. Okay. All right. A couple of you guys are still a little lost, but a couple of you guys were gone yesterday. That might be another reason why. Remember, whenever you're absent, I think didn't we really quickly yesterday recap on my website? Did we or did we not? Oh, we didn't. Okay. Where am I right now? Website. We had quite a few people gone yesterday, so I'm just doing a quick recap as in, like, how do you catch up if you're gone? Could you just borrow someone's notes, have them screenshot, whatever, take pictures and send them to you? Sure, but what's on the website? Number 1, the PDF copy of the book from chapters 1 through 3. That's one thing, right? If you want the full version, I did get one email last night and I couldn't find it to email, but I just figured out where it is, and so I'll email it right now. But there is the PDF version, and if you email me, I can give you the full version that you just have to download. Okay? There is the class calendar that shows you basically when our next test is and all the in-betweens. We're right here, and next test is in about 2 weeks on Chapter 3. Shows you where the homeworks are, etc. Wait, Google Classroom, it only shows you like the next homework, right? Because if I showed all of them, it gets confusing, like finding the right one to post in, etc. So remember also your class folder, right? What's in your class folder, guys? Homework sheets for entire chapters. You can just print it out and have every single homework assignment and not need to go look in Google Classroom. Some of you guys that have some data issues on your phone, it might not be a bad idea to print it out and not need to check Google Classroom until you're home and needing to post or able to post. But anyway, all the homeworks for Chapter 3 are in there just chilling. You can see that we have, for instance, Section 3.2 has been split into 2 pieces. So check out the back board. Today we're just doing 3.2a, which has its own homework due tomorrow. Then we'll do 3.2b, which has its own homework. So we do have a homework due tomorrow, but this section's kind of long. I split them into 2 pieces. So go ahead and keep an eye on that. This is the homework due at 7 a.m. But anyway, the homework sheets are in there. But also, If data's kind of rough, you're trying to update your notes really quickly, I do update every day with a little bit more as far as what we cover in each chapter note. So it's one big file for every chapter, and you can go through and write down, oh, we didn't do examples on. We need to get back to this page, huh? But it does show you the notes for the day. And then last but not least, what would probably be a really smart idea if you miss class as far as how to not fall behind? Watch the YouTube lecture. Now you might be like, oh, but sometimes you guys waste time talking about, yeah, it's true. So why don't you put me on like 1.5 speed or double speed until there's something important, and then slow me down and take the notes, etc. Right? So if you're absent, if you're gone, you have the YouTube lecture that you can watch as far as us going through notes step by step. You have the PDF version if you just want to copy it down quickly and then just listen to the video. And you have the homework page if you ever want to get ahead, and Google Classroom doesn't show the getting ahead version of homeworks, okay? Oh, and the class calendar. That gives you a snapshot as far as what's coming. Okay, just wanted to really quickly, since we had quite a few people gone, make sure that we're all on top of what to do when you're gone and how to not fall behind. All right, cool kids. Go ahead and turn in your homework to section 3.1 with your colored pen at the ready. I'm just making sure with these last couple examples that you guys didn't get thrown off with E. So open up your notes real fast. Just one quick little boop boop that we need to add in that we didn't get to yesterday. Just one quick little add-in that we need to get to or write down. But I think you guys should have been okay as long as you've seen E before, which I think you have. You should have seen at this point, whether in chem, whether in physical science, that might have been a little advanced for physical science. Or in algebra 2. But real quick, who is this dude E? We plugged him in our calculator yesterday, didn't we? E to the 1, I think. And E to the 1 was approximately 2.718281828. Yes, there's a pattern. Unlike pi, there's definitely a pattern to E. He's called the natural number. That's his name. And he's seen in all sorts of different special types of growth, from continuously compounding interest, having to do with interest and how interest grows, to exponential growth and decay of decay of radioactive elements, population growth. It's kind of crazy that a lot of these different types of growth and decay, even like populations dying off, can be modeled with this little guy E. Kind of points to there being design in nature. Pi kind of does that too. The golden ratio kind of does that too. The Fibonacci sequence kind of does that too. There's some pretty cool patterns out there that don't really make sense if it came from chaos. But anyway, coming back. I just wanted to make sure you guys knew what to do if you saw an E to the, not just a 2 to the, not just a 3 to the, but an E to the. How could you get X, guys, if both sides had an E to the? Yeah. It's just like the one-to-one property. I mean, there's an E there instead of a number, but you're allowed to do the exact same thing of saying, sweet, one-to-one property. I can just focus on the powers and say, well, E, whoever you are, all I need to know is when will 3x plus 2 equal 3? And some of you are more experimental in that you're like, hey, can it be 1? Can it be 2? Can it be -1? Maybe you'll solve for it that way, but the rest of us, the algebraic steps of subtracting 2, dividing by 3, and there we go. So why did I do 2 examples? Did I think you guys wouldn't get the one-to-one property or would be so confused by E that you would kind of just check out? Why is E harder, though? Louder, Matthew? Yeah. There's an x squared and a constant and a, hey, there's an ax squared and a bx and a c. Who is this guy? Quadratic that needs to be factored. So remember, if you need to factor, you need to get everybody to one side and in the proper spots, or else you're going to have some issues. Hopefully pretty quickly. Oh, that doesn't work. Oh wait, that does work. Ah, nice. Sometimes the 2 and 3 works, and sometimes the 1 and 6 works. And it's confusing sometimes as to which is which. But negative 2 times negative 3. What x negative 2 plus negative 3 is negative 5. Just wanted a quick reminder. If you guys see a quadratic, get it all to one side, then factor. Okay? Get it all to one side, factor. All right, for those of you guys that were gone yesterday, you might want to quickly just ask someone in your group, like, hey, how many notes were there, just in case you didn't get it, you know how many pages to skip, et cetera, because we are going to go on to section 3.2. So as we grade homework, if you don't have it ready, make sure if you're ever absent and you need to post a homework late, you weren't able to watch the YouTube video and stay on track, et cetera, make sure you post a comment for me. But you could be borrowing someone's notes right now to go ahead and catch up and at least figure out how much space to skip before our next section. And for the rest of us, let's go ahead and grade. So, section 3.1 shouldn't take us long. And for those of you guys who did homework, did it get pretty rough or was it all right? Good. Perfect. That's exactly what I hoped it would be. It's a nice, easy, fundamental start to chapter 3. Number 2, transcendental, straight out of notes. Number 4, natural exponential, natural number. You might not have totally known all of those unless you went looking last night. But we just wrote those down in our notes. Number 10 was just a, hey, do you know how to use your calculator and the caret button? And the answer should be 0.544. And then we started using some graphing clues to make some matches. Number 14, hopefully you guys got, was C. And number 16, matches B. We good? Remember, if you're getting 100% on these homeworks, give me something like a check mark or a -0 when you're done to let me know that you're keeping track, participating in class, checking if you have the right work, and asking questions if you don't, okay? Number 24, one-to-one property. Make 16 2 to the 4th, and all of a sudden, booyah, set them equal and solve. 34. Can you use your calculator and the caret button to graph? Hopefully. This guy would have been what? Shifted left 1 and down 2? Could have done that by hand. 52, there were e's, but hopefully they didn't scare you away. One-to-one property says take the powers and solve. X equals 5 halves or 2.5. 76 was bonus. Okay, real quick for anyone who tried it. It was a little crazy. What you had to do was see the addition and the exponent and be like, wait, exponents get added when like bases get multiplied. That was the key. This was an optional problem, so some of you might have been like, yeah, no. For the rest of you, exponents get added when like bases get multiplied. So you could have broken this guy apart, and all of a sudden, this is just a number. 2 squared becomes 4 to the x, and all of a sudden it matches what you need it to be. All of a sudden it matches what you need it to be. 64 times 4 to the x is another way of writing the original expression. They mean the exact same thing, and if you were to try to graph both of these guys, they would be the same. But if you tried those two, nope, wouldn't have worked out. All right, guys, that's the end of our homework. Any questions on evens besides 76? That was an extra credit problem. Or odds? That's what I like to see. Are you sure, though? Going once, going twice. Okay, sold. Let's get to section 3.2. Quick reminder, and if you weren't here, you should hear it in the video. Quick reminder, chapter 3. Puzzles. We're trying to get to the point where we can solve the harder ones at the end. Video games. We're trying to get to the point where we can make it through the harder levels that are coming. Or actually, if you just want to do a Fortnite example, we're trying to get out of the playground. Actually, maybe we're not even in the playground yet. Maybe so far we're just trying to figure out what the different options are as far as what the buttons do and what our weapons are and what's this whole building a house thing. Anyway, we're trying to get the main idea in sections 3.1 and 3.2. Just like, what are the main players? Like, what's the objective? Then, like section 3.4-ish, then we'll get in the playground at least trying to kind of play using all of our skills. Like the very, very basic version. If you're thinking of Sudokus, hey, Sudokus, grab out your reflections. If you're thinking of the Sudoku example, 3, 1, 3, 2, 3, 3 are like, what are the rules? Like, what's the point? 3, 4 is like, let's give you a very easy one, and then like an easy one, maybe even a medium one. And then 5 says, okay, let's go hard. Maybe not expert level, but all of it's preparing. All of it's preparing. Okay, reflections. Anybody figure out that that second one was kind of hard?
Yeah, second one's kind of hard.
You cannot possibly add 3 odd numbers and make it even. It is an impossible problem, which is why yesterday I told you have to think outside the box, but that wasn't specifically what you were supposed to do. And I did this with my paper and said you had to think outside the box and consider things from a perspective. Did anybody figure out what it meant on the one you were filling in the balls adding up to 30? The 9 can be turned upside down to be a 6. And then 11 and 13 and the upside down 9 adds up to 30. It wasn't like an Uno card with a line, so you had to keep it like it was. I know, you haven't taken your test. Here, do you want one just so that you can play with it? But it's not due until after you take your test.
Yeah.
Who figured out the 6? Yeah, Harana did. Joe did.
Because like if
Who's trying?
yeah, they have a dot.
Or like Uno cards. Don't they have the lines? Isn't that the line with the Uno?
Yeah.
Yeah. So yesterday I was trying. I was like, I think outside the box. Not literally. Think of it from a different perspective. Anyway. What'd you guys get for the first one? The visual brain teaser about looking down on the stack? It is A. It's a lot of yellow with a little bit of whatever that color is. I don't know. A lot of light with a little dark with a little light. If you guys look close, a lot of light with a little dark with a little light. First one is A. The second one is in whatever order you did it, 11 and 13 and upside down 9. Or a right side up 6. I don't know. And how about the Sudoku at the bottom? Did you guys figure it out? Yeah. How do you know if you figured it out?
Check it.
Each number is only used once, every row, every column, and every box, but pause. Compare with your group real fast because it's hard to check it like as a class. Compare and see if the numbers are the same. It was a little harder than last time though, huh? It was a little harder than last time though, huh? 3.2 is logarithmic functions, that's A, and their graphs B. So if you want, as far as like matching it up with homework, that's going to be section A, and then the graphing part is section B. All right, here we go. We talked about exponentials, now it's time for logarithms. How many of you right away I say logarithms and you're like, spirit sinks? You're like, meh. Only a few? All right. Some of you just didn't want to admit it, or you didn't realize I was asking for a raise of hands. Most of us don't like logarithms, but it's just a tool. And if we learn how to use them, we got this. This guy, you guys know his name? Nope. He's a common log. This one's a natural log. And where do their names come from? Ready? I'm going to teach you how to cheat. Not really, but kind of. Didn't I have you yesterday go find the buttons on the calculator that pointed to exponential functions? Right? Don't worry, he's getting out of the way. Come on. Come on. It's okay if you don't have it today, because I can show it up here and model it. Yesterday we talked about how we can use the caret button to do to the power of. And then we talked about how we can find e to the power of. Wait a minute. What button did I hit to get e to the power of? Ah, it's a cheat trick. Since e is what's above ln, guess what ln, what kind of log he is? There's no base shown. There's no base shown because they're understood bases. ln is technically a log base e of x. Just the shortcut notation is ln, which I know is weird. Natural log is ln. That's okay. I bet the ln didn't come from English. And maybe it makes sense if we know some romantic languages about how adjectives come after. Anyway, coming back. So ln is natural log, which is technically a base of e. What do you guys think common log's base is? Look at the button on the calculator. What happens if you do second common log? You don't get an e to the power of, you get a 10. Hey, it's a reminder. It's a reminder. Common log is log base 10. So you're not going to see the bases, you just have to know what they are. So a common log has a base of 10, a natural log has a base of e, and the nice thing is natural log has the natural base, the natural number as his base. But every other logarithm, the base should be shown. If it's not a 10, if it's not an e, the base should be shown. Let's talk about this guy. Just like we did yesterday, we got to talk about our main players. 3.1, exponential, 3.2, logarithms. Log base a of, oh, base a. Base a. Okay, a is the base. And not just any base, he needs to be a constant base. And if you don't see him, then he must be an ln or he must be a common log, so you should know him. Every other base will be shown. X is a variable argument, we'll say. Bless you, bless you. X is a variable argument, kind of like a square root. So it's log base a of x, not times, of x. And y is the logarithm. Y is the, bless you, is the entire thing. Is the logarithm is the entire thing. But let me give you a quick hint. Logarithms actually are just ways of talking about powers of the base. Logarithms were kind of developed to specifically be able to deal with the powers, to get to the powers of the base. And I'll try to model that for you guys down here in letters A and letter C. There is a way to put this in your calculator. And we will make sure that you know how to use your calculator buttons. But both of these actually are really, really, really nice answers, not decimals, because of a very specific reason. If I was to plug in 32, 2, log base 2 of x. If y is supposed to be the power of a, if y is supposed to be the power of a, that matches, check it out. I can rewrite 32 with a quick little factoring tree. Let's see, he's 8 and 4, 4 is 2 and 2, 8 is going to be what, 2 cubed, right? 2 times 2 times 2. I can rewrite this to be 2 to the 5th. And if the entire logarithm ends up equaling the power of a that makes it match, well guys, gives us 32. Go figure out how to plug that into your calculator to make it say 5, because 5 is the right answer. You can work as groups. Go find the log button. No, not any log, log base 2. Ah, I can't use common log. I can't use ln. What about the math menu? Ooh, ooh. If someone doesn't have a calculator, turn so they can see it. Where's the log button? Not common log, not natural log. Ooh, math menu? I'm following Jason. The rest of you guys find it yet? Anybody with a calculator without a yellow button? You are good, you are golden, you are ready to go. Because log base says, hey, I got you. And you're like, sweet, thanks. There's a 2, there's a 32. I got 5. Huh? If you have a yellow button, you have to use something called the change of base formula that we all have to memorize anyway. It's just not going to be on the screen yet. If you have a yellow button, just sit tight and hang in there. Oh, this is easy. All we got to do is rewrite the argument as a power of the base, and then answer. So this guy, easy cheesy, right? Plug in 2. Okay, log base 4 of 2 equals log base 4 of 4 to the power of... Plug into your calculator. What's log base 4 of 2? And then let's try to work backwards and say, okay, what power of 4 is 2? What do you guys get? Log base 4 of 2. 1/2? How does that make sense? If that's a half, then that has to be a half. If that has to be a... Oh, wait. What's a half power the same thing as?
Half of the numbers.
No, not half. Square root. Isn't the square root of 4 2? 2 can be written as the square root of 4. Square root of 4, that's 4 to the 1/2. 1/2 is the power of 4 that makes 2. So what if I was to do something crazy, and what if I was to say, hey guys, mental math it. I'm going to put it in my calculator so we can check it. But what if I was to ask you for log base 25 of 5? What would the answer be?
1 over 5.
Not 1/5. You're close though.
1 1/2.
1/2. Because isn't 5 the square root of 25? Ooh, so question. What would be log base 81? What am I going to put in there?
9.
Is that going to be 1/2 too? Nice. So wait. What if I was to do, okay, I'm not going to do a half. Hold on. Keep your brain engaged. What if I was to do log base, I don't know, 4 of 64? 4 times 4 is 16. 16 times 4 is 64. Oh. Cubed. It's 3. Logarithms give powers. What powers? The powers of A that make whatever is inside. So why is this one going to be a nasty decimal? If I go ahead and do log base 2 of 37, why is that a nasty decimal?
Ew.
Right? Can 2 to a power be 37?
No.
No. But what's 2 to the 5th?
2 to the 5th.
4, 8, 16, 32. Is it 2 to the 5th and a little bit more?
Yeah.
What are logarithms? Just powers of the base that make the argument. Maybe we know a little bit more as to what a logarithm actually is. So what if I was to give you something? I don't like either of those. What if I was to give you something like, I don't know. Log base 3 of 17. I know, that's gross. Well, but some of you might be like, well, 3 squared is 9, 3 cubed is 27, so it's somewhere between 2 and 3. We can do logarithms in our head? That's cool. Those of you guys that have the yellow button on your calculator, you're kind of like, well, that's sad. I can't do the change of base. Sorry, I can't make this in my calculator. Here's what you can do. A cool property of logarithms is we can go from any base that's given to us, and we can change it to be another base just by a simple division. Which in the olden days was the only way. Olden days, it wasn't that long ago, but before the newer calculators and the newer operating system. This is what we had to use, this idea, because this idea would let us take any log of any base and say, hey, we can use the common log button as long as we do a division. Or, hey, we can use the ln button as long as we do a division. So you can solve for this, not just using the math and the log base button, but you can solve with a common log and say log of 17 over log of 3. Or you could also do it with ln of 17 over ln of 3. And it would be the exact same answer as if you had done it with the log base button. Does that kind of make sense? So you can, it's the exact same. ln of 17 over ln of 3, he just checked it, log of 17 over log of 3 equals the exact same thing because both of them are just snazzy ways of representing or transforming this guy into another base. So change of base formula. You guys should have seen it in Algebra 2. I'm sure you did at some point. Probably don't have it memorized, though. Oh, yeah, there you go. Logarithms are definitely used in chem as well. Okay, what other fundamental things do we need to know about logs before homework? There are properties. Okay, there are properties, but I want to show you what these properties actually let you do, because that's the point as far as using them for homework tonight. Okay, I am going to zoom in on the properties. If you guys want to grab out your phones real quick and take a picture. I want to show you how to use the properties, because that's what's going to help you on homework. Not just knowing them. You can write them in your notes. That's okay. When you have time, there are 4 of them. But I want to show you what we can do with them. And actually, to be honest, you guys should be able to do letter A right now, just based on what we've already done. We said every logarithm is just a power of the base. So guys, if we check out this guy, this whole logarithm is just going to equal what? What's this? What's this is power of 11?
It's just 7.
But there is a snazzy property up here to say, anytime you have log base a of a to the x, you will always get the power. So there is a property called the inverse property of logarithms that lets you know that this is always true. This one's a little harder because there's nothing. Wait, hold on. It's pi to the 1. Oh yeah, that's just 1. Pi is what power of pi? 1. Now, this one's a little bit harder, but let me rewrite. 1 as 3.2 to the anything to the 0 will always be 1. So any log of 1, there's a property for that. Any log of 1, well, it's always that thing raised to the 0. So you're going to use the properties up above in order to solve. Now, having the properties down and having, there's a 1-to-1 property too. Hold on, wait. So I can do stuff like I did last section? Oh, yeah. Because what's true about the logarithms, guys? They have the exact same. So just like we did with exponentials, you can say, well, hey, if they match, there's a 1-to-1 property with this guy also. Answers are always pretty and nice. We saw that, bless you. Logarithms can be decimal, bless you. Man, it's a struggle. Retreat goddess. But guys, these properties are going to allow you to tackle some basic problems that allow you to develop the beginning skills of logarithms. Sound good?
Yep.
All right, get out of here. Finish the harder Sudoku, play around with it. But also homework 19, 3.2a is due tomorrow.
You didn't post homework in full classroom. It's not there.
I did 3.1.
I mean 3.2.
Uh-huh.